E1 is equal to L2 minus L1. L1 is the unstretched length because that is what they asked us to calculate. Hi guys, welcome back to my channel. Today I want to solve some simple mathematical problem related to the Hooke's law expression I gave the last time. Okay, I'll just be solving some waec questions, one or two examples, and trusting that you'll be able to solve any question related to Hooke's law. Okay, so let's go there. This example 1. Example 1 question. A spiral spring extends from a length of 10.00 centimeter to 10.01 centimeter when a force of 20 Newton is applied on it. Calculate the force constant of the spring. What is the force constant? Now the force constant is K. That is what they ask us to calculate. All right. Okay. So from the question, we know that it's from Hooke's law, and they ask us to calculate the force constant K, which I have my K equal to F over extension. Okay, now you bring out what is given in the question. They said a spiral spring extends from a length of 10.00 centimeter is the original length of the spring before the 20 Newton force was applied on it. So we can set L1, let L1 be the original length, is equal to 10.00 centimeter. It's in centimeter, you have to change it to meter. In changing it to meter, we divide by 100. All right, so if I divide 10.00 centimeter divide by 100, I will have 0.1 meter. All right, that is my initial length of the spring. They said, okay, from a length of this to, now this is the extension now, or the increase in length. So increase in length, let me say L2 is equal to 10.01 centimeter. This is my L2, my increase in length, right? I'll also change it to meter. Why am I changing them to meter? Because the basic unit of measuring length is meter, and we always use the basic unit in performing calculation. So this, if I divide this, I am going to have 0.1001 meters. Okay, so my extension E is equal to L2 minus L1. So I have L2 minus L1, okay, which is equal to, my L2 is what? 0.1001 minus my L1 is 0.1. All right, so if I subtract this, I'm going to have 0.0001 meter. All right, so this is my extension. The next thing we need to get is our force, which is already given in the question. Okay, so applying K is equal to, my force is 20 divided by my extension, which is this 0.0001. okay, now this is going to give me what? This, if I divide this, what I should have is 0.00002 Newton per meter. All right, this example 2, And the question is, a spiral spring has a length of 14 centimeter when a force of 4 Newton is hung on it. A force of 6 Newton extends the spring by 4 centimeter. Calculate the unstretched length of the spring. Now this is under Hooke's law, and if you recall, the expression of Hooke's law is what? K equal to F over extension. All right, X over extension. Okay, now in this question you have to understand the question and know when you are going to apply this. Okay, now the first part of the question said a spiral spring has a length of 14 centimeter when a force of 4 Newton is hung on it. This is an increase in length from the initial length, that is the length when the force was not on it. All right, so we can call this 14 centimeter as L2. I have it as L2. That's increase in length is 14 centimeter. Okay, when a force of 4 Newton is hung on it, so I can have F1 is equal to 4 Newton. All right, now the next part of the question is a force of 6 Newton, that's F2, this is my 6 Newton, or L2, F2 I mean, is equal to 6 Newton. Extend the spring by 4 Newton. This word extend, that simply means this is my extension. So I am going to have my E2 is equal to 4 centimeter. Okay, these are the parameters given in the question. Now, if you recall from this is the expression of Hooke's law, right? So we have from here, we are going to have extension E1 is equal to L2 minus L1. L1 is the unstretched length because that is what they asked us to calculate. Calculate the unstretched length. So L1 is the unstretched length while L2 is the increase in length here. So my extension E1 is equal to 14 minus L1. All right. So since it's the same spring that we have these two extension and these two forces, we are going to have for the K1 is going to be F1 over E1, which is expressed as what? K1 now is equal to my F1. This is my F1, 4 over my E1, which is this. I have 14 minus L1. Good. So my K2 is going to express as F2 over E2. So my K2 is equal to my F2 is what? Is 6 Newton. 6 Newton. Then my E2 is 4. Okay. Now, since it's the same spring constant, we are going to have K1 equal to K2. I will substitute this. What I'm going to have is, this is my K1. I have 4 over 14 minus L1 equal to my K2, 6 over 4. All right, in this order. So this is the mathematic. I'm going to apply mathematic principle now to deal with this length. So the principle I'm going to apply here is cross multiply. This will multiply this and this will multiply this. So I have from here, I have 6 open bracket 14 minus L1 close bracket equal to 4 times 4. All right. So opening this bracket, what am I going to have if I multiply 6 times 14? this should give me 84. Yes, I will have 84, and 6 times minus this, I have minus this, okay, in this order, equal to 16. All right. Now the next thing is I'm going to collect like terms. That is, I have a term that is different from the rest, so I will carry this one to this side, this one will come to this side, and this 16 will come to this side. You know, mathematical principle, their sign are going to change. So what I'm going to have here is 84 minus 16 equal to 6L1 in this order. Okay, so if I subtract 84 minus 16, I have 68 equal to 6L1. All right, so the next thing is I am going to divide both sides by the coefficient of L1, which is 6. 6 will cancel 6, so I have my L1 is equal to 64 over 6. All right, so I'm going to have L1, if you divide it, you are going to have 11.33 centimeter. This is my final answer for the unstretched length from our question. So thank you. Please do well to subscribe, like the video, share the video, click the notification button for more information when there is an update. Thank you.